Welcome back to the SSAS training sessions. In last session, we discussed about translations and perspectives. So in this session, let's try to cover partitions and aggregations. Before going to the partition discussion on partitions, I would like to show a couple of things on analysis server. So the first one is where the data will be stored when you process an analysis service queue. Let's say you selected the storage mode MOLAP, sorry, and MOLAP storage mode basically means that the data will be stored on the analysis services. But where in the analysis services? Let me show you a couple of important things that you need to know before discussing about the partitions. The first one is the data storage, where the data will be stored. If you don't specify while installing, like, okay, store my database related files or data files in a particular path, the default path will be taken if you don't specify uh, a particular path of your interest. Now the default path is go to program files, go to Microsoft SQL Server, and you can see MSAS 12 and dot MSSQL Server. So MSSQL Server is the instance name, the default instance name. If you provide some other instance name like XYZ, then it will be MSAS 12.xyz. If you go into this folder, you can see OLAP folder, and if you open the folder OLAP, then you can see backup, bin, config, data, log, and temp. So the data folder is which is very important. This is where the data will be stored if you process a database. And if you see the AdventureWorks gw.db, then this is the database which I deployed to the server, and this is the another database I deployed to the server. .db extension means it's a database. When you open the database, then AdventureWorks DW .ds is data source, .cub is cube, similarly the dim, and each and every object will have an XML file which keeps the definition of the object. This is more like cube structure, but in the folders. Let's say you have a 4 dimensions there, and you can see 1, 2, 3, 4, 5, and 6, and there are total 7 dimensions in our database. So you have all the 7 dimensions here. Each and every dimension is having a separate folder, and if you select that folder, it will be showing the data that is present in the folder. In the same way, if you go to the cube, then you can see two major groups, fact internet sales and fact reseller sales. And if you go into the fact internet sales, there is a .prt extension. What is the PRT extension? That is nothing but partitions, which we'll be discussing in today's session. So this is one thing. The other one is, if you go to the same path, the installation path, the data folder where it is installed. If you go to MSAS 2012 under OLAP, along with the data folder, you can see a couple of other important folders. The first one is backup. This is where the backups will be copied when you take the backup and select the default folder path. And config, this is where the configuration about the server will be having. Like if you see the msmdsrv.ini file, this will have the complete configurations about the server. So if you open it, normally you can open it with Notepad. If you open it, you can see an XML configuration where it will specify everything, like, okay, the data directory is, this is where we have gone, right? We have checked now. So under OLAP, under data, this is where the data, this is the data directory. Similarly, the log directory information, similarly the backup directory information, and allowed browsing folders information which users can access. And you have lot of, say, temp directory folder. This is the temp directory where it will store all the temporary files which are required during processing of the database. And deployment mode, and if you see there are something about security tab, and network related, and commit timeout, and so on. So all these properties, you will not have access to these properties, because changing of any property will have impact on your cubes. Now, this is one thing. Let me go back and let me show you other folders. The other important folder is log folder, where by default the crash dumps and msmdsrv.log and the trace files will be stored. What are these things? The crash dumps are basically when the server is crashed with some error or due to some error, then it will generate a dump file. So these two, the .log and the .mdmp forms one dump file. This is a mini dump. Okay, there are two types of dump: mini dump and full dump. Mini dump will capture very little information. Full dump will capture the complete information. What is on the server at the time of crash, everything will be captured. So once the crash dump is generated due to the server crash, then we cannot do much here. What we need to do is we have to share it with Microsoft for further analysis. So if you share these files and say that, okay, our server is crashed and can you help us on this, then they'll analyze the crash dump and they'll come up with the root cause, like, okay, you try to do something and because of that it failed or it crashed, or some of the files which are required by analysis services are blocked by antivirus, so something like that. So MSMDSRV, on the other hand, this maintains the information about um, when the server is started and when it is stopped and so on. So if you see here, and also some of the error information, if it encounters any error, then it will store that information too. But very importantly, it stores the server start and server stop information. Um, you can see the service is started at 7:44 a.m. on 8/28. And better go with service. Here you can see 28 at 8:02 a.m. the service is started, and find next, and 8:57 a.m. the service started, and so on. And also it gives some see login failed for this service. When I try to process on a particular day, I still remember on 20th. So when I tried to process it threw error saying that login failed for MS SQL. Then I provided the required permissions to process it. So it will capture few error information and also the service start and stop information, which is very important. If the service is stopped and you can easily identify whether the service is crashed or service is stopped by some user. So if the service is crashed, there will be a record for service started and so on so date, and let's assume it's crashed today. Then there will be one more record for service started without service stopped information. If it is service stopped by some person, then here it is started, right? The service is in running mode. Let's say I stopped it today. Then there will be a record saying that service stopped here and then service started here if I restart the service. So if there is no information about service stopped, that means the service is crashed or the system is bounced. The computer is bounced or something like that. So this helps when you are working as a DBA or app DBA. Else you don't need to concentrate much on msmdsrv.log files. And the third important files here is trace files. The trace files is the one which will have the complete information or complete activity information on the server. If you see the trace started, and it will have all the processing commands and whatever I executed on the server so far. I can search it by Control F. I can see command find previous. If you see there is a command executed by me, and the command is to process full of Cube Adventure Works GW. So this is how this profiler trace is very helpful to find out the errors and to find out the activity on the server, whether the server is idle or not, how many queries are currently running, and how many users have triggered queries on the server, and how busy the server is. You can get the complete activity information about the server. And if you want to find out the live information, this is like file. You need to open it again and again, or once you open it, you need to refresh it because let's say there are some XYZ number of rows, and if you refresh it, the fresh data will be coming. So instead of this, you can you can start the profiler trace, which will be capturing the information live. For example, for that you need to go to search. There will be something called profiler, and if you open it, it will ask you need to select the new trace, and you need to provide the server information. Once the server information is provided, you need to select the columns or the rows that you want to see. So I want to see the information about command begin. I don't want a discover event, so I can uncheck it, because there'll be huge data for discover events and some of other discover server state events. I don't need this information basically. And error information I need, if the server if encountered any error, then it will be shown in the error messages. And file load, I don't want. Logs, at this point I don't want, but you may need it when you're working on logging issues. And I don't want notification events. I want progress report events, which means what's happening when the cube is processing. And here I want query events, because I want to see what's happening when the query is triggered, and query processing events too. Apart from the security audit, I don't need, and sessions I don't need. So sessions means basically it will give you who all logged in into the server and what is the current session status. Okay, now the trace is running. Whatever you do on the server will be tracked here. For example, let me process it. I'm going to the cube, and I'm processing the server, and you can see the information is traced. It is processing for the fact table, and it finished processing. So something like this, it will have the complete information, and it will give you how many records it has read. You can see this is integer data, right? So it gives that, okay, 60,398 records read. Here up to here it is 60,000, here 50,000, something like that. So you'll have the complete information like data reading, how many records has been read, and also when it started, and what is the SPID used for this, and what is the object that is processed, like fact internet sales is the object that is processed, and who triggered it, and more information like when it is started and when it is stopped, and so on. And also above all, it will give you the command which is triggered. This is the command it is triggered. You can use this command for your jobs also, like instead of opening the wizard, and instead of executing executing from wizard, you can use this command and you can execute from SQL Server Management Studio going forward, instead of opening the SQL Server data tools every time. So this is about the profiler trace, and I can clear it if I don't want this information. And now everything is set. We have a cube ready, database ready, and we have a trace ready, and you have idea about msmdsrv.log file and msmdsrv.ini file, and also the data folder where the data will be, and what are the folders that will create. So as I told you, there are two partitions created, for each measure group. So that means when you created a measure group, okay, when you created a measure group, like I created two measure groups here, by default one partition will be created with the name of the measure group. The measure group name is factory seller sales, so there is a partition created with this name. And if you want to see that, and you can see that under the queue factory seller sales, and you can see there is a partition created with that name, and in that it will have the data like this. Okay, you can see 75.fact.data, 75.fact.data.hdr. Now let me go back to the cube and let's discuss how to create more partitions and what is the use of partitions. So partitions, when people talk about performance improvement, you can improve the performance in two places. One is processing time. Let's say processing time is taking 2 hours. You can improve it by adding partitions, like you can make it to 1.5 hour or 1 hour. Okay, and the second one is querying performance, how the querying performance will be improved. The querying performance will be improved if you create the partitions. The partitions will create the slicers, and the slicers will help in improving the performance. So let's discuss about these two. The first one is how to create the partitions. then how it will improve the processing time and also the querying time. First, before creating the partitions, let's see how it improves the processing time. Let's say this is your database table, fact table, and it has 1 lakh million records, and this is one partition you have. That means this one, the folder. So one partition folder created. What it will do is the analysis services, when you process it, it will read the data from here to here, and it will read the data, and you have seen how many records it has been read. It was showing in the trace file like 50,000, 60,000, 60,398 was the last, because it has 60,398 records. So what will happen is it will read 10,000 records or 20,000 records or max 50,000 records per second, and it will push into the single partition. So it takes a quite some time, right, to process the complete records or complete data from the fact table, because it has only one connection. So it can make only one connection, one partition, only one connection. So it will read data from one through the connection that it has made to the database. Let's assume you created month-wise partitions or year-wise partitions, which will increase the number of partitions to 20 or 30. Now what it will do is it will have the parallel connections. So if your hardware is too good and the parallel connections, once it's at the parallel connections, it reads the data in parallel. So once it started reading data in parallel, then the performance, the time it takes to process the queue will be reduced, because there will be parallel connections and the data will be read in parallel. So that is the main reason, main advantage. If you set it to the parallel processing, then the performance will be far better than having one single partition. And remember, the performance difference you can see only when you have a good amount of data, something like 10 million, 20 million, or 30 million at least. If you have 60,000 records like we have in AdventureWorks, then it takes fraction of seconds to process one partition. You can't see much difference even if you have multiple partitions or single partition. So try to get a database where you have huge data, and try to try to process with one partition, and then try to process with multiple partitions and see the difference. You surely see a lot of difference in the processing time. Now this is why the processing time will be reduced. Now let's see how to create the partitions. So basically, users create partitions based on date. 96, I mean, I can say 70 to 90% of the cases, people create on dates, because that is universal data and it won't be changed and it is fixed one. And the other reason being, lot of queries will be fired based on date. From the MDX, from the dashboards, people query the data to the from the cube using, I mean, with the where, with the date in the where condition. So that is why people prefer to group the partitions or to create the partitions based on dates. And other reason is the data is fixed. Like January 2011, that is fixed. If you create partitions based on product, the products will be changing. If you create partitions based on geographies, the geography names also, I mean, it's not limited, it will be changing, right? But here it will be dates greater than, I mean, 2011, 2012, 13, 14, and so on. Here, let's see, let's try to create partitions based on some date. I'm going to the partition. Before doing that, before creating the first partition, what you need to do is you need to modify the existing partition. So the existing partition, if you see, or the default partition, which analysis services created when you added the measure group, is basically table binding one. So table binding means it pulls the complete data from the table, from the fact table, and it will load into the partition. That means to the partition folder. In our case, it is fact internet sales dot to dot prt. This partition, it will save all the data into the partition folder. What you need to do is first change it to query binding, and here I need to add some condition, like to restrict a few set of records into the bucket, into this particular partition. So for that, I'll create a query to get only ship date 2011 information. Okay, first let me connect to the database and let me prepare the query in my SQL Server. I'm going to new query, AdventureWorks DW, and this is the one. I'm writing inner join dim date on dim date dot date key is equal to fact internet sales dot ship date key. So if I join these two, oops, 1 second, I missed something. Inner join dim date on dim date key fact internet sales. Mistake. So it is not inner merge join, it's inner join. So let me go with this query, and you can see it is retrieving the data. Now I would like to find out what are all the different years that are available for the ship date. So I'll write this calendar year distinct. I'm just trying to find out what are all the partitions I need to create. If you see, I have data for 2011, 12, 13 and 14, 4 years. So what I'll do here is calendar year is equal to 2011. So this guy will fetch the fact data only for the year 2011. So I'll write this query and I'll click on OK. Now this is a query binding and it pulls only 2011 data. Okay. Now let me name it as 2011. And let me go to the next partition, and I need to select the table on which I am building this partition and specify the query, and I'll name it as 2012. Next, and I'll name it as 2012. I don't want to design aggregations now. Finish. And let me create for 2013 and 14 too. Click on next, fact internet sales, specify the query, and here it is 2013. Let me name it as 2013. Finish, and let me create this 2014, 2014, and let me name it as 2004 fact internet sales 2014, and I'll design the aggregations later. Click on finish. Now if you see, the most important point here while creating the partitions is you should not miss a record or you should not repeat a record. For example, if I add one more partition and if I say like add same query, and let's say I've given 2011 again, and let me name it as junk because this is junk. And if you see here, I'm reading the data from the fact table for the year 2011 twice. That means the duplicate data is coming into my partitions. That is really a big mistake. The data mismatch will happen and people will say that the data is not correct compared to the underlying data source. So let's say the sales is $1,000 for the 4 years, then it will show $200 extra, like $1,200 it will show because I am reading the data for the particular calendar year twice. So make sure that you are not reading extra data. That is one important thing. And also make sure you are not missing even a single record from the fact table. If your business requirement says that you need to pull the complete data from the fact table, and let's assume you missed the data for the year 2012 or 2013, then it will be problem, because if the total sales is 1,000, it will show less than that because we are missing data for a calendar year. So here it is 2014 and 2013, and everything. Oops, the name should be with space. Okay. Now I created 4 partitions. What will happen? Let's see now. I will process the whole database now, whole cube, and this time I'm not going to use the wizard. Instead, I'll show you how to do it using the XML query. Oops, I don't have that XML query. I'm sorry, I'll do it next time. For now, let me adjust with the processing through SQL Server data tools and processing wizard. So if I click on process full, if I click on run, and you can see the partitions fact internet sales, it is creating more partitions. If you see here, 2012 one partition created, 14 one partition created, 13 one partition created, and 11 it has not created with the name 11. The reason being, normally it takes the ID. Okay, so if you see the partition IDs, this partition 11 was created with the name fact internet sales. If you see the ID here, the ID is fact internet sales, but the name is 2011. So it has created a folder with the name 2000, fact internet sales without the suffix, 2011. Now you can see this is the use of partition. It will group into separate folders and it will make the parallel connections. It will read the data in parallel from the database, from the underlying database, and hence it improves the performance of your queue processing. Now let's go and see each and every partition folder. So this is for 2012. If I open it, I hardly have 3 files. One file is having fact data. This is the file which has the data, which has the actual data that has been read from your fact table to the partition of year 2012. And this info.xml will have information about this partition. We'll see that. And 2014, it's again the same fact data and it has info.xml. And 2011, the same, it has fact data and the info.xml. And here if you see, this is slightly different. The 2013 year, it has fact data, like the files is size is 1730 KB, and it has info file, and it has a lot of other files which we call it as slices. So what it will do is it will try to identify the different combinations. I'll show you an example here. If I go to the info file and if I open it with the Internet Explorer, and under map data indices, you can see for the customer and the geography key of the customer, the geography key attribute of the customer dimension, the minimum index is 2 and maximum is 337. So if there is any request between these two data IDs for the geography key, then it will come to this particular partition. It will come to this particular partition and it will scan the data. That means it is saying that, okay, this partition has fact data that is related to the customer geography key with the indices 2 to 33. Minimum is 2, maximum is 337. If there is any request like for 3 or 4 for customer geography key 4, geography key 5 and so on, it will come here and it will get the information. Now if you go here, let's concentrate on this. So product category is a dimension and English product category name, and this particular partition has data for minimum index from 2, starting from 2 to 4. What is this 2 and what is this 4 for English product category name? We can write this is a data ID. We can write an MDX to get the data ID. Let me show you what is this 2 and what is this 4 means and what all covered in this product category name. So for that, I need to connect to the analysis server. I'll show you this is not of high important, but let me show you this helps out. This gives you a better idea. So let me go to. I'm writing a query, MDX query with member data ID value as data ID of. Let me take this. Select data ID on 0, and we are interested in product category, English product category name, right? So English product category name on 1 from cube name, and here you need to get this information. Shift home, copy, and so I'm asking the server to get the data ID of every member in this particular category. And if you see accessories, the ID is 2, bikes is 3, clothing is 4, and components is 5, and unknown is 1. So if you see, this particular partition has the data which has the fact information which covers the product category, English product category name for clothing, accessories, and bikes. So these three, 2 to 4. The minimum value is 2, maximum value is 4. So if there is a request for bikes, then it will go on hit that particular partition. Okay. So this gives extra power, like while querying, instead of scanning all the partitions, if it has to scan all the partitions, then it takes a lot of time, right? So instead of scanning all the partitions, by taking the help of these slices, it will come and hit this particular partition, and it will get only from data from this partition. Okay, so to happen like that, to filter or to scan only one partition, what you need to make sure is every partition has the slices information. Let's say this guy has slice information and remaining 3 does not have slice information. Like this partition does not have slice information, this partition does not have slice information. So what analysis server will do is, first it will go to the partitions which has slice information. Where is that? This one. And it will check whether the requested attributes or the dimensions has members in this one or not. If it has, then it will scan that and it will get that information. Then it will go through each and every partition which does not have slice information, because analysis service does not have any clue whether those partitions has data that is required for the query result or not. So it will scan the remaining partitions which does not have slice information, and then it will publish the result. Let's say you have 2 partitions with slice information and 3 partitions without slice information. Okay. Now this partition says that it has data for 2011. This partition says for 2012. And this partition does not say anything about the slice information. Now I send an MDX query which says get me the data for the year 2011. What it will do is it will come and check here. Okay, it has 2011 data. It got that information from the slice information available in the partition folder. Then it will query from here. Then it will come and check. This does not have a 2011 information, so it will skip this. Then it will go to the next partition. This does not have slice information at all, so it will scan and to find out whether there is any data related to 2011. Then it will go to this. It will scan everything because it does not have slice information to say whether it has 2011 data or not. So it will analysis server will scan this and try to find out or try to pull the data if anything found related to 2011 year, and then it will go to this. So in this case it will scan 4 partitions. Let's say every partition has the slice information, and let's say this has 2013, this has 2014, and this has 2015. Then if you execute the same query, it will hit only one partition because the other partition slices is telling that it does not have 2011 information. So thus the querying performance will be improved. So the querying performance will be improved only when you have slice information for every partition. If you have slice information for every partition, then it will say, okay, don't hit this because it does not have the required member that the query is looking for, or the query has in the where condition. Let's say the where condition is 2011, then it does not have 2011, then it will skip this partition. So instead of scanning through all hundreds of partitions, it will go and get the data only from couple of partitions which has the required member that you have specified in the where condition. So this is how, if you use partitions, both the query as well as processing time will be reduced. And the most common question here is like how many partitions you created. In an interview, people ask like this, or how many partitions max you can create. Until 2005 or 2008, it's limited, like I think up to 2005, 2000 partitions per measure group. Now that limit is lifted. You can create n number of partitions and there is no restriction in creating the number of partitions. But the problem is the performance of maintenance thing like backup, restore, and sync will be in trouble if you add more and more partitions. Let's say the default time taken to to back up a database or to sync a database which is 100 gigs in size and with only 5 to 10 partitions. Let's say the time is 1 hour, and if you create 2000 partitions on the same cube, then for the same database sync or same database backup, it will take more than 4 or 5 hours. So the number of partitions, if you increase the performance, it will be in trouble for backup, restore, and sync jobs. Apart from that, there is no such limitation like you have to create only 1000 partitions or 2000 partitions, but again it depends on your requirements. If you're getting data daily, you better create daily partitions, and at the same time you better purge or delete the old partitions which are not required for your analysis. Now we will come back to the point. Now let's concentrate on why this is not creating slices and why the remaining part, only one partition is creating the slices. The reason is in your config file. Okay, let me go to the config file. I think I have one more folder open for that. This is where you have the config file, and if you open it, there is a property called index build threshold. So if you see here, it's set to 4095, and that means if a partition has at least 4095 records, then only it will start creating the slices information. So let me do one thing. Let me change it to 100. I'm setting the value to 100. That means if the partition has at least 100 records, then it will start creating the slices. So this is just a value. In real time, every partition you will be having at least 1 million records. So you don't need to worry about this property in real time. But our database has very less number of records, and that is why I set the threshold value to 100 to make sure that the slices will be created for every partition that we process. So now let me go to the profiler trace and let me get the query. This is the command begin. Instead of going with the SSDT processing wizard, I'm gonna use SQL Server Management Studio to process. Now I know what query will be triggered when I process the whole cube, right? So to use the query to process the database, what you need to do is you need to right click on the database and new query, and you need to select XMLA. So we call these queries as XMLA queries. Click on XMLA. XMLA stands for XML for Analysis Services, and copy the query. And if you see, it is a batch command run in parallel and for on this database on this cube ID. And what you want to do, process full. And if I execute this, let me clear this to see what happened if I execute it. And you can see the query is triggered and we started reading the data, and it's perfect as expected, and you can see it's completed successfully. Now this is one way of processing and most frequently used way in analysis services in real-time projects. Okay, people don't go with bits every time. Only during development people will be using the bits, and rest of the time they will be using SSMS for maintaining the analysis service database. Now let's go and see what happened to our partition folders. So if you see the partition 2012, you have slicer information, and if you see for 2014 you have slicer information, and this one you have slicer information, and even the last one you have slicer information. That means the partitions it has created, okay, the partitions we have created is reading at least 100 records. I set the threshold value to 100. That means if you get more than 100 records, then it will start creating slices. Earlier, it was the default value was 4095, and hence it was not reading. It was not creating the slices because it was not getting partitions was not getting enough records to start creating slices. Okay, this is one part, how to get the slices. Then in real time you don't need to worry, as you will be getting some millions of records, always more than 5000 records, so you don't need to worry about creating the slices. Now let's see what we have in each and every info file for English product category, right? So let me go to 2011 first. Let me open it in Internet Explorer, and then let me go to 2012. Let me open it in Internet Explorer in the next tab. Similarly 2013. This is the one which will be having the information about the slices, right? So let me go to 2014 too. Oops, I think it's 2011. Um, if I go to info.file, here it is, and I can open it with Internet Explorer. Now let's take for everything, for all the 4 files, what is the product category. So this guy has only for the data index of English product category name 3. That means, what is 3 here? It has only bikes related information. Okay, now let's see the next one, 2012. 2012 has also for 3. That means it has only bikes related information. And let's see 2013. The minimum value is 2 and maximum value is 4. That means it has accessories, bikes and clothing. If you query any of these 3, then it will scan this partition. If you query for accessories, it will scan this partition. If you query for clothing, it scans this partition. If you query for bikes, it scans this partition. And let's go for the 4th one and the last one. This is again minimum value is 2 and maximum value is 4, and it doesn't know what is the remaining values that are present in between. But if you query any value between 2 and 4, then it will scan this partition. Okay, now let's do one thing. Let's try to query accessories. If I try to query accessories, what partitions it should hit? It should hit the last partition because it has 2, and it should hit the last but one partition, that is 2013 partition, because it has 2, the minimum value starting from 2. But it should not hit these 2 partitions because it's saying that the slice of information is saying that there is no accessories level data available in these 2 partitions. Correct? Now let's try to write a query and let's see what's happened in the trace. I'm clearing the trace. I'm going to SQL Server Management Studio, and let me write a query. Select, I'll try to get the sales amount on 0, comma. So we are going with product category, English product category name, and we're going with accessories. On 1 from the cube name. So before going ahead, because I refresh the cube and all, there will be some information taken here. So let me clear it in the trace and let me execute this query. So I'm executing query for accessories and it will return the data. And if I see the partitions it has read, you will have that information here. So it started reading data from the partition 2013, 2014, and it finished reading data for 2014 and 13, and it started calculating and building the queue. Now if you see, the number of partitions it scanned for the data is limited. It didn't go through all the partitions. Now let me do one thing. Let me erase the query and let me go ahead with bikes and let me execute it, and let's see what partitions it hit. So it's hitting 11, 12, 13 and 14. So it's hitting all the partitions because all the partitions has chance of having the data for bikes. Now let me go with the third one, that is, what is the ID 4? Clothing, right? Let me select clothing. Clothing is available only in 2 partitions, that is 2013 and 14. Let's see what it will query. You can see it hit only 2013 and 14 partitions again. So thus it will try to save lot of time. It won't go to, see, this is a small database. This is perfectly fine. Imagine a database with 100 partitions and each partition is having 1 crore of records. So for scanning 1 crore of record, let's say it takes 2 to 3 seconds or 1 second. It's gonna save the time if your query is very much clear with the slice, with matching with the slice information, and if it needs to hit only 2 to 3 partitions, then it's gonna save lot of time, right? Query execution time. So thus it will, the partitions improve. Partitions with slices, remember that partitions with slices improve the performance of your MDX queries. Now everything is fine. Let me go to the XML again, the slicer information. Let me see what I have for color. There is okay, product color. This guy says product 2 to 11, and product color is 2 to 11. Similarly, product color here, this guy again says 2 to 11, and what this guy says, I'm checking the product color for each and everything. So this is again, this says 2 to 8, and what is the last one? So this guy says 2 to 11. So most of the partitions are covering 2 to 11 information. So what is this 2 to 11? And only one partition has 2 to 8. What about the remaining stuff? If I need to get the data ID, again I have to use this, but for color this time. Color attribute of product dimension. So let me do the same in the rows. Product color. If I execute it, you can see 2 to 11. So that means it has all the products information, and only one partition has 2 to 8 information. Like if you see from starting from, this is 2011, it has 2 to 8 information. The products from the color to starting from data ID 2 to 8, this partition has data. And if you query anything in the silver or black, white or yellow, it won't hit the partition, this particular partition. Let me show you that example too. Let's try to query for white. White will not cover in that, right? Cover in the 2 to 8. So the first partition has only 2 to 8, and the remaining partitions, if you see pretty quickly, it has 2 to 11, it has 2 to 11, it has 2 to 11. So all the three has 2 to 11 except the first one. Now I'm picking the 10th color, the color with the data ID 10 in my MDX. And before going ahead, let me clear this data, and let me execute this. Now if you see here, the partitions it started reading, and it started reading 12, 13 and 14, but not 11, because the slicer information is telling that the first partition with the name fact internet says 2011 does not have the data, the fact data related to the color white. So this is how you can save the information. This is called automatic slicing. So when you process, and based on the threshold value set in msmdsrv.ini file, the partition slices will be created